Hey everyone, so today we're going to be looking at transforming exponential functions. What is an exponential? An exponential can be used in real life when you're trying to solve a money problem. For example, if you're trying to find the interest or annuity. And the basic formula for an exponential is y equals ab to the power of x. Alright, there are two different types of exponential functions. So there's an exponential growth and exponential decay. Now, first we're going to be talking about the exponential growth. When looking at exponential growth versus a linear growth, as you can see, it kind of builds up a little bit faster, and you will find that the numbers in the table of values when you're looking at this will start to grow faster. While as you look at the linear growth, it kind of is a little bit steady and it grows at a slower pace. Alright, now let's dive a little deeper into exponential growth. So looking at our equation, y equals ab to the power of x, in order for the exponential function to become a growth, b has to be larger than 1. So looking at some examples I put here, y equals 2 times 3 to the power of x. This would be a growth because 3 is larger than 1. This would also be a growth even though a is smaller than 1. So keep in mind that only b has to be greater than 1 for it to be a growth. Alright, so now we're going to be looking at our exponential decay, which is the other type of exponential function. So looking at it versus the linear decay, as you see, goes straight down and will drop at a faster pace, while the exponential decay will take a slower amount of time to fall. Alright, so exponential decay. Looking at our formula, y equals ab to the power of x, in order for it to be an exponential decay, b has to be smaller than 1. Now looking at the examples I put down in red, y equals 0.25 to the power of x would be an exponential decay because 0.25 is smaller than 1. Now looking at the second example, y equals 4 times a half to the power of x, it would also be an exponential decay because our b value, 1/2, is smaller than 1. Alright, so now that we know a little bit more about exponential functions, let's talk about the transformations that we're going to be doing in today's video. So we're going to be looking at vertical stretch and compression, horizontal stretch and compression, a reflection on the x or the y-axis, a horizontal translation, and a vertical translation. Alright, so as you can see that I wrote in red here, this is the formula for the exponential function. Now you're probably thinking, but you already told me that the formula was a times b to the power of x. Well, it is. This is what we would call the parent function of the exponential function. This, in fact, just opens it up a little bit more and shows us each different part of the function and what each letter can do to the function. So when we're looking at it, a and c affect our function vertically, and k and d affect our function horizontally. Alright guys, so first we're going to be looking at our a and b value. So looking at our a and b value, it would pretty much be the same thing as writing this formula right here, a times b to the power of x. But we know that a affects our function vertically. So I decided to put 2 as the a and 1/2 as our b value. So looking at this formula I made right here, you can see that 2 is our a value. So we want to stretch our function vertically by 2, and our b value is 1/2. So I automatically know it's going to be a decay. Alright guys, the next letter we're going to be looking at is our k value. So we know that our k value affects our function horizontally. Now this could mean that it could either be a horizontal stretch or horizontal compression. So I decided to put a 2 right here for our k value, which means that we have to stretch our function horizontally by a factor of 2. Alright, when looking at reflections, they can either happen in the x or the y-axis. When they happen in the x-axis, you're dealing with this letter right here, a. But when it happens in the y-axis, you're dealing with this letter right here, k. So I chose to reflect my function over the y-axis, which means I'll be dealing with k. So if you look at this red function, which is what we drew with everything but our reflection, it is going and decaying to the right. But when reflecting it over the y-axis, which is this middle line right here, it becomes the blue line. So now it's decaying to the left. Alright, so our next letter we're going to be looking at is D. So in our formula, D is found right here. And we know that it affects our function horizontally, which means it's either moving to the left or to the right. So I chose to do x minus 6 as part of my formula. Now, remember, just because it says x minus 6 does not mean that you move to the left. it's always the opposite of what it means. So it's actually moving it to the right. So if I'm starting with the red function right here, by moving it over 6, it becomes the light blue function. Alright, so we are going to be looking at the letter C. Now this is the very last letter in our formula, so it's the very last transformation you will have to do to your function. So the letter C is found all the way at the end of our formula. So I decided to put in our formula 5. So we'll be moving our function up 5, which means that the C value impacts our function vertically. So as you can see from this blue function right here, this is what we had before we had our C value, but then with adding our C value, you move it up 5. Now this is the last transformation we'll be doing, so this is what our final function will look like. When graphing all of our transformations on a piece of graph paper, this is what it will look like. Each color represents a different transformation that we did, keeping in mind that our purple function is our final function. Thank you guys so much for watching, and I hope this helped you learn how to transform exponential functions.